So, good evening, everyone. So, if I may ask, if you have gone through the slide, what do you understand by networking in your own um in your own? So, any other
Uh,
person?
Networking, in my own, yes, in my own perspective, networking is the connecting of two computing devices, uh, like through a shared medium, so that they can share information and resources together.
That's interesting. So, yes, networking is actually a connectivity. Yes, if there's no connectivity, um there will be no communication going on in that particular area, right? So for me to be able to speak to you guys, I have come and I have opened my Telegram and I have literally turned on my video chat and I am already talking with you guys, right? So that's networking. Do you get it? So networking is the connection to leading to communication of a particular device so that they can literally share information if one is sending one, another is sending one, and communication goes on, right? So let's move. Um, in what is networking? Networking is the connection of two more devices to actually share resources. In real life example, we have internet, we have LAN, and we have school Wi-Fi, right? Then purpose is to share data, resources, um, and also access and resources and also communicate, right? That's the purpose of networking. So one thing you must understand about networking is that the main reason is to share data, to communicate, and to give resource access. Like when I was coming, like when I was trying to set up to teach you guys, something happened and they were asking me, I've connected my Wi-Fi to two of my devices my in my house, right? So I was trying to set up, do everything, and immediately my fire was like, okay, should I connect to this Wi-Fi that is available here or there? And I was like, okay, let me allow access to my Wi-Fi that is coming, that is inside my house. So and immediately gave access and started the call immediately, and everything is fine. So if that access wasn't granted, we will not even possibly be having this call. So yes, types of network we have PAN, right? Personal area network. This is a usual small unit of network, right? Me, I stay in should I say a one room self-contained, right? So maybe if we are in a very smaller room, just your laptop, maybe people that stay in one room personally, they have just their laptop, their phone, or possibly a Wi-Fi, right? So PAN is that little communication that happens only in that room, does not cut across any border, right? It doesn't cut across anybody else. Nobody is seeing that they are nobody. Everything is just within that small room that they are. So that's why. And if you're operating PAN, you may just have your Wi-Fi, your laptop, what else? You can have other devices um around too. Laptop and even if people that are rich, they usually have smart TVs. And everything is just within that house, right? No other person is going to actually tap into that resources and all. Then we have LAN, like LAN is local area network. This is um a kind of network configuration for small offices, right? And people that have kind of a large home, right? It's a local network for connectivity down to the internet, right? So LAN majorly people that I've seen, they always, if you are using LAN, you always have for people that are connecting their home and all, you have just your Wi-Fi, your laptop, maybe your desktop, and then um, your smartphone and maybe other devices that are inside your small office, right? So that's LAN. It's local area network. Just something. It's not that big. Like when you are discussing LAN, just a simple network configuration for that particular office, right? Then we have metropolitan. Metropolitan is bigger than LAN and PAN, but not bigger than WAN, right? So metropolitan is just a connection, but it's cuts across. Let's say let me take redeemers now, or which school should I use? Use Redeem ecosystem for explaining man, right? Redeem has an empire, right? If you have gone to their camp, right, they have connections here and there, they have routing. Redeem is just like a whole new world, different from Lagos practically, or even different from Ogun State that it's in, right? So in that campus, there are network configurations, right? Inside that everybody are getting resources, everybody are having access to the internet, everybody are sharing resources, but it's not bigger than, because this man is actually limited to a certain area, right? Like campus, right? It is limited to a certain area. Nobody access apart from the whole building structure and how it looks like in the university. Outsiders cannot access those network outside. Outsiders cannot literally access them. So it's majorly for that particular campus. That's man, right? Metropolitan. But it's not bigger than one. One is the biggest of them all because it in it's actually the connectivity and connectivity. It has a wide range of connectivity. That's why we are able to even communicate, as you are seeing now. Where I am in Lagos. Some people are in Mina. Some people are in different part of the world, same. Yet you still have the ability to communicate with them, right? That's one wide area network. So it's a connection of different computers globally from your locality down to the global space. And that's why you are able to communicate through Facebook. You send somebody that is in UK, unlike before that will have we'll have to send letter and it may take months, right? So with just messenger, you can just ping somebody in UK and how far I'm coming over to the UK next week, blah 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 blah. That's one. So it's an interconnection, is wild. That's why it's called the wide area network. So it's used for communication across just your PAN, your LAN, and your MAN, right? So it's beyond. And the tech using one are way bigger. You use fiber optics, right? You use fiber optics this thing because it supports it supports actually a large communication procedure, right? It can take millions. That's why the internet, which is the internet network, is built on LAN. It's built on one, yes, because we are able to communicate diversely to different people from different tribes, even Tanzania, UK, US, Russia, Afghanistan, Iran, Pakistan. You can be able to communicate to as many people as you want. So these ones are not usually limited, right? So when we are talking about the bandwidth of one is very big that it can accommodate many people, right? But you see, PAN, right? PAN is just limited to a person, right? Just his devices. It can't accommodate as much. And that's why I use when I was describing PAN, I said it's a small room, right? Where you are communicating, just devices communicating to one another, nothing more. Then local area network is still the same devices, but in at least a much larger space than PAN, right? Then man is not as big as one, so it's just more like a set location. In in banking industry, they use man, right? Metropolitan network. It's not big, It just has a set goal to communicate to different devices, and that's how a bank is able to get a lot of information, share information. That's why you can walk into any bank and say, okay, oh, I want to access my database from this branch. Maybe you're in Ogun State and you just walk into any access bank and be like, oh, I want to access my access bank stuff. I give them your name, give them your account number. You see, they'll just pull everything up. So that interconnection it has a boundary, right? It has a boundary. So it's not giving access to everybody, right? This man, pan, and LAN, they don't give access to everybody. But when you are talking about one is a global thing, right? One is a big thing, is a very big thing. It connects everybody together, right? So if I'm watching, let's say I'm the kind of person that personally I love watching animes, right? So in order to meet my anime fellas that are outside here, not within my borders, I can send them, ping them on any social media platform and be able to get them. So one has a very large network structure to accommodate a lot of people, right? So that's literally the difference between one pan, LAN, and man, right? So let's move on. Hope you guys understand me. Okay. So personal area network, like I said, types of network. Personal area network. Personal area network just connects few devices. Like you can see, this guy just has his tab, he just has his laptop, and he just has his phone in his small apartment, enjoying life. So that's how it is, literally. So very small, no much devices and all, right? Then we have LAN, local area network, is the connectivity between small office, right? In offices, you may have different computers from different sections, and switches, servers, and all printers. So in order for these communications to occur within that office, right? That's where LAN. So it's based on your location, your locality, where you are currently. The communication does not exceed that locality, right? So that's LAN. Within that your office, that's where communication is, right? Everybody, once you send message, the messages are very prompt. Once you send anything, they are very prompt, and that's how it is generally. Then we have man, right? I said man is not all that big, right? Man is not all that big, right? It's not too big like that, like than the area than the wide area network, right? So let me just explain this. Man can be multiple LAN owned by a particular organization, system, or anything. Like bank now, let's say this is bank A, bank B, bank C, bank D. So for communication to be able to occur across that network and everything be okay, they use man, right? So no matter where I am in any bank I walk up to, they can be able to process my own information and give me feedback. Maybe if I request a statement, it will give me feedback and all. So we have wide area network, like I told you, it's an interconnection, big interconnection of systems, right? It's a big interconnection of systems globally connected to one another, right? So even from my room, there may be another person in their house. Everybody, it's a global thing. That's why we are able to communicate properly from different nations, and we don't have any flaw or any lag personally. Then we have network topology, right? We have we have hybrid, right? Okay. Bus topology is a configuration where all devices connected to a single or shared cable or backbone, also known as bus, right? So, yes, bus topology is a simple topology. It's just a connection between one, a single connection or a shared cable. Now, if you look at, I went to write exam, jam, right? And when I was trying to do something, and I discovered that literally they're using bus topology, right? So all devices that are interconnected to one another are using a shared cable, right? So they actually outlined this everything actually connected every single desktop, right, to a particular CPU. Yes. So if I happen to do anything that would cause the flaw, every other person within that environment, right, would be affected. Within my own environment would be affected. So bus topology is just is connected to a single or shared cable or backbone. This cable is known as this is also known as bus, right? So it's a single connection with one PC, maybe like 5 desktop having connections to one PC. When I mean PC, I mean processing unit, right? So the processing unit of it, well, that's literally powering up those desktop, giving those desktop a shared information, right? So that's how it is for boss. Then we have star topology, right? Star topology is a connection, right? This is a star network topology. All network devices, computer, printers, etc., are connected to a central point, right? Um, Often a hub or a switch, which acts as the central hub for communication, right? So now, the star topology is a connection that allows people to connect, right? But there is a central point that ensures that communication goes from one system to another and another and another, right? I think my school used when I was in secondary school, we used ring topology, right? We have ring topology. We have like three, yeah, we have four connectivity, right? So in our computer lab. So star topology is having a central point, and this central point is the one responsible to the communication. And in each topology system, right, they have admin, right? In my school, if that time we when that's ring topology, we're using ring topology. We have a round desk connected with different about 10 systems. Then we have an admin, and that's it about topology. So if now let me give you an example, right? So now let's take a look at this, right? If this is the admin system, right, and others, these are minor subsidiary systems in topology. Now we use a switch or a hub to actually be the center communication between all devices, like all the computer devices there. So now, let's say now we want to we just came into the office and the admin system is not on, right? If the admin system is not on, others will be showing, right? So once the admin system turns on, right, it sends a communication through the hub, right, and allows this. You normally you could turn on your devices manually on a norm, right? But when it comes to authorization, right, and authentication, right, before others can be able to input their password as subsidiary users like guests, right, this admin system has to be on. If not, they won't be able to access their personal information practically. So what the communication that happens here is that once the admin system it logs in, it sends communication to each and every device, right? Guys can now log in. I'm in, right? So the admin system then validates each and every other system, which I call guest system. That's how the staff topology works. So even in transferring of data, right? Even packet transmission, you understand that if A, I call F1 wants to send communication to device, maybe a file, right? And it can send these files to each and every one of them. And even the printer will receive, maybe if it's a Word document, the printer will receive it and then prints it out. That's how stack topology communication works. And I told you we'll be dealing with networking in a very large format. So I'm still going to be showing you guys some things, right? Because the networking is not something that you can just finish in a day. It's usually larger than you think. So we have ring topology, right? You can see it's usually a ring format. The ring network topology is a network configuration where each device is connected to two other devices, forming a circular or a closed loop, right? So in my school, this is the kind of topology we use, right? That to our printer, to our stuff. We want to print any system or device, right? This is how we use, this is how it is in my own school, right? Ring topology is that configuration that connects each and every device that creates a loop, right? So if I'm sending information, that's why if we want to print, right, because we are in a ring topology setting, right, we could literally send a document to our they have a major system controlling um the ring topology system, right? That's the ring network topology system. So if you want to send files to the printer, right, we can literally just send them directly to the printer to actually send the communication down to the printer, and it keeps going. So for each of the devices that are outlined, that are in circular format, they keep sending um, information and communication or anything that wants to happen within that topology. So if you want to send a lot of stuff, bulk documents to print, it immediately goes in and the printer starts executing. Once we say print, yeah, that's how ring topology works. So we have mesh topology. This kind of topology is a very complex topology. It takes a lot of bigger organizations to actually partake in this. I've not seen any organization with mesh so far, have I? No, I haven't. So there is mesh topology. Mesh network topology is an architecture where each device node is directly connected to multiple other devices, creating a network of interconnected paths. Right? So computer A is connected to computer B is connected to computer C, and that's how mesh topology is. So it creates a large connection, right, where each system is connected to one another, right? So they are it's a direct connection, right? So if A is connected to B, B is connected to C, C is connected to D, and that's how it keeps going, right? So that's mesh. Then we have hybrid topology. Right? Hybrid topology combines two or more different network topologies to leverage their strength and minimize their weakness, right? So yes, you can in your network setting, right? If you're doing a network configuration for a big firm, you can actually connect devices or match topologies together, right? So far so good. You can merge bus and start together, then use a central hub or switch to be the communicating system. That's when if you're dealing with subnets, right, you understand how communications move from one level to another. So this is to leverage their strength and minimize weaknesses, right? But even in that, right, even in this topology, it can be intercepted if not properly configured, right? So communication that is meant to go to um, this system is going to actually be going to another system, right? That's what I call MITM, right? So this is like the central node, right? Balancing the communication between this ring topology system to a star topology system, right? So this might be a switch or a hub sending good communication. That's it. Then let's move. Let's dive. So pros and cons of topologies, right? Boss, boss topology, simple, cost effective, easy to install, and good for small networks, right? Then we have cons. That single point of failure, main cable, limited scalability, performance degrades with heavy traffic. Right? So now for this, and one thing about bus topology is that the system is compromised, right? You have within that topology. So imagine that I was writing jam, right? And now went to go and do something, maybe do a code audit within that bus topology network, right? To affect other guys and they may end up failing their exam. That's one thing about bus topology. And we have star, easy to manage, scalable, failure of one device doesn't affect another, right? Like you see, this is for this failure of one device affects other devices, right? Right? Central hub failure disrupt the network, higher cost due to more cabling and central device. Right? So in star topology, it requires um, a lot of communication, right? And if there is no, if the communication is not that large, right, it's going to, if the communication is very large, it's going to cause a lot of disruption, and it requires high cabling. Right? You may use. It depends on the cabling method that the company wants to use. So central hub failures disrupt the network. So if there is a kind of um, a disruption with the hub, that's the central hub, it affects every system in that particular network topology. So we have ring equals to resources, equal access to resources, predictable performance, no collisions. Yes. Now, yes, I told you something about ring, right? So I told you that everybody can access resources, right? So if I want to send resource to anybody, any school, within that network topology, right? I can literally send information to those stuff, my printers and all. So it's equal. Every system has equal right to access. If there are no authorization methods set, every system has equal right to send information, right? Even though there are still authorization placement, right? Informations can still travel across and get to my printer, and the printer brings them out. So they have equal access to resources, predictable performance, no collision at all. Right? So it's not going to actually cause a jam. If computer A is sending, computer B is sending, computer C is sending a Word document for it to be printed out, everything gets printed out without no collision at all. So the single point of failure, one break stops the network, difficulty to reconfigure or expand, right? So single point of failure, right? One break stops the network and difficult to reconfigure, right? So if there is a misconfiguration, right? Single point of failure is, let me just give you what that thing means. Single point of failure is when a device, right? It's when a device actually fails to work, right? It fails to work totally. Everything um 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 stops working, like all the configuration, everything goes down. So it has the single point of failure is very disastrous. And anybody that has a large networking component is going to be very hard to reconfigure or expand. Very difficult, right? So that's why it's very advisable if you have money, just do the one that suits you. But it's going to be very hard and it will take longer time, right? I remember when we had the single point of failure in school, whereby we were trying to sort out resources, connectivity, and all, right? We discovered that we discovered that um, it took a longer period of time. We were trying to do some Python stuff projects that time, small projects. We had a lot of problems. Yes, a lot. So we couldn't use our main computer room. We have a subsidiary computer room, so we had to move there so that we could carry out that practical. So single point of failure, which is I think is it not SOF? Yeah, SOF. Yes, it's very critical. So it really shuts down every communication within that system, right? And communication no longer flows. So whatever information you send from one system to another in a ring topology, it doesn't get to that system, right? So we have mesh, highly reliable, no single point of failure, supports heavy traffic, right? Expensive, complex to set up, manage, and requires significant cabling, full mesh, right? So mesh is actually very expensive, right? So that it's highly reliable, no single point of failure, support heavy traffic and all, right? So it's expensive on the other side, right? It's expensive on the other side, complex to set up, right? And if you have a misconfiguration in mesh, it's going to be hard to literally get back on your feet. Or literally, mesh is usually maintained. That's why it's going to require a very skilled network engineer to be able to maintain your mesh configuration because it's literally wide. Then we have hybrid. Hybrid is flexible, combines benefit of multiple topologies, scalable, right? Complex to design and maintain, can be costly depending on combination, right? So what actually takes a lot in all these system and configurations are the wiring and routing, right? And also maintenance. Yes, maintenance is very important when you have larger network communication, right? So if you're expanding to maybe a hybrid topology, it's flexible and it's easy, right? It's scalable, and but the thing is that it's complex to design and maintain, and be costly depending on combination, right? So if you want to merge, if you want to merge um a normal network, right? A normal, let's say, ring to a star. If you consider you may be spending averagely, let's say $5,000 to 10, if you want to do, and even maintenance, because you'll be paying people to maintain the whole network configuration, the switches, computer maintenance, everything joined, right? So all those things are part of the combination of the network topologies that you are going to be seeing, right? So uh, okay. So network devices, right? We have switches, we have routers, we have access points, we have modems, right? We have hubs, right? Hubs, a router usually have an Ethernet port, right? Switches too, do, they have a LAN and they have Ethernet port. Now, this is a switch, right? So these are different LANs, or like you can connect different routes, different desktops to this switch. Then we have an outsourcing material, right, which is called Ethernet. Ethernet is the one outgoing sourcing from the ISP, right? That's Internet Service Provider. And we have router. Router can also do the same thing. It can but just that it has limited ports, right? So it's very advisable if you want to do a larger communication, you can use switch as the main stuff, right? Then we have hub, and we have modem. Modem is like smaller version of router. They usually have They have NIC, right? For routers and modem, they have NIC. That's network interface card, which is usually also known as MAC, right? The MAC address. So MAC is the one that ensures certain things are in place, resource sharing and communication. Then we have access point, right? Access point is the point of access, usually SSID, right? SSID broadcast. That's why with this, you can create what we call rogue access points. Yes, whereby once a communication is set, right, it then channels that communication out to maybe the attacker, right? So everything about that communication once you are connected to a rogue IP, which I think I can show you, but I think set is not properly configured for that. So yes, so that's rogue access point. Yeah, that you can actually use it to sniff communication, a lot of communications and all within a particular network. Then we have routers. Let's see. A router is a networking device that connects multiple networks like home and the internet, right? So like I told you, it connects devices, right, to the internet directly from your ISP. Right? The primary function is to forward data packets between this network, ensuring that they reach their intended destination. And then we have functions connecting networks, forwarding data packets, data flow. Then we have switch. Switch is an electric component that opens or closes an electrical circuit. Yes, controlling the flow of electricity. It acts as a gate, allowing current to pass through when it's on or close position, stopping flow when it is off or open position. So it's used number one, it's used to control circuit flow by turning off device at one point or another, or protecting components, ensure network connectivity, then WLAN support. Right? Network connectivity is the ability to share data from one point to another within a subnet. Right? A subnet is like a a a a, a group of computers topology allowing communication. So I'll give room for questions. If you have any questions, you can ask. Does anyone have any question?
Okay, yes. I'm just going through the what you just said, like orb and modem, they are having the same definition. Why is it like that?
Modem and what?
And orb, they are having the same definition, like what you just explained. If you just go through the
Modem, right? Let me
yes,
explain modem. Modem is this very small, scalable device. It's usually if you're using it for personal use, it's usually scalable. You can move it from one point to another. But um, sorry for the error. When you use when you are using a modem, right, it's usually scalable. It's something that you can carry within the pocket, right? A hub, a hub is a hub or switch. They can be used in a network topology setup. Now, because a hub too also receives signals, right, within a network topology communication. So interchangeably, you can even use a hub or a switch. Yes. So, but the thing is that the communication protocol for a hub and a switch, they are different. I, I think for a switch, it actually transmits a lot of packets, right? It transmits when you send a a packet now from one desktop to within a topology, right? So you're sending a communication from one topology to another, right? Once you send that communication out to that particular desktop or whatever devices that are in that topology, right? What it does is that it shares, because it doesn't know the system. Maybe you want to actually put that information down, right, to maybe computer A or computer B. So because it doesn't know, it sends the information out generally. Then once the actual system that actually allows that communication happens, right? It then takes that information, right? While others, they may not really use that information for anything, right? So it takes that information and gets the work done and send back the communication. I'll teach you MAC address when we get to subnetting. I'll teach you MAC address modeling and network communication. How packets are transmitted from one point to another within a system. So I'll teach you that. I'll show you a live communication from my system. I have a small topology in my house, right? From one system to another. You see how communication goes. So I'll just show you a difference between a router and a hub and a switch. Sorry for the error. I didn't even go through the slides properly because it was my designer. But everything being well. So yes, let's move on. We've talked about switches. We've talked about modems, right? Modems are short forms of um, modulator and demodulator. Is a device that converts digital signals from a computer into analog signal or transmitting over a network, vice versa. Its primary function is to enable communication between devices using different types of signal formats, such as computer and the internet via telephone lines or cable network. So, long distance communication, um, and data transmission, yeah, and also data compression. It actually breaks down data into smaller units called bits, right? So it compresses data to smaller units. Is there any other question?
Go on.
Okay. So we have access points, right? In our next class, I'll be showing you how all these things work in real time about networking basic, right? So, which will be on Saturday. So yes, access point, right? An access point works by receiving data from device and transmitting it to the network. It converts the data into wireless signal or broadcast. That's why I told you it produces a broadcast, SSID broadcast, right? It's over a specific frequency or channel. So if you want to hack a Wi-Fi, you understand all these things. Don't worry, that's why I'll show you how to hack Wi-Fi. So your device then recovers the signal and can communicate with other devices on the same network. Right? Functions of the access point and bridging wired and wireless networks, extending network coverage, improving network capacity, managing network security, and also providing wireless connectivity. So like I told you now, the access points can be manipulated, right? Somebody can create an access point, right? Because it's a broadcast, you guys tend to see that information publicly. And once you connect it, the main purpose of the access point sometimes is to steal information, right, from an individual and all, right? And an access point can be rogue, right? So I can decide to create a rogue access point, something very crazy, very rogue, right? So that's how it all works. Then we have addressing and subnetting. I believe that I'll stop here because on subnetting, it's a whole new ball game. because it's bigger. You guys have to understand it better. So if you have any question now, you can ask relating to what we've taught. Then on Saturday, yes, I'll be teaching network subnetting, addressing, and all you, because you learn a lot of huge terms and you'll be seeing them in reality. Right? I'll show you all of them in reality. So basically, for the assignment that I've been giving to you guys, right? All you just have to do is make proper documentation of that assignment and make a post tagging HSC direct, and we'll be reposting most of the assignments that have been done. So I'd like to stop there. If you have any questions.
Just that topology, like what's the function of this network topology? I really don't understand the concept. I don't know if you can just give me in a very simple form. Let me just understand it.
Yeah, okay. Thank you for that question. So topology, what does it help do, right? Topology help communication to be a lot easier, right? So one thing that we looked at in the process of networking is connected device having the ability to communicate with one another, right? So now, right, if I want to share a file, right, to a device or laptop, normally, what I'll do is just connect Bluetooth, right, and I'll send the file. It's very slow, right? I'll send the file to the person and the person receives the file on his own end, right? Now, what a topology does is that for larger organizations, right, big organizations, it allows communications to be very, very easy, right? So now, if I don't have to come and be unwiring and dewiring and doing this, if I want to send a file to a printer in an organization, I just need to do, because of there is a topology that allows maybe in a subnet. That's why I usually break this thing down, because subnetting is big. So now let's say we have first floor, second floor, third floor in a very big organization, right? What does topology help do? And we have printers, we have other functioning device, right? So if I want to, like now, I have been to a bank whereby the printer wasn't there, right? The printer wasn't in the hall I was, or in the room I was. What did the guy tell? He just said, okay, please be patient. Let me go and get the document from downstairs, which means that the endless computation very easy of topology. This guy sends the file from a, a different subnet or segmentation. Let me not say subnet, a different segmentation. That's the top floor. And he went down to the ground floor and picked up that printed document to come and issue it to me. So topology helps communication easy, right? And it makes work easy. So instead of me unplugging, I will now unplug to connect to another system. If I have a very good routing process, that's why network engineers are very, very sweet and interesting people, right? So if I have a communication to actually do some things, send files and all, maybe somebody wants to receive a file from a segment in the bank to another segment within the same bank, they can decide to send the file or escalate issues from top to get to the people that um um that would need that information, right? Have you ever been to a hospital before, right? And I mean very standard hospital, right? And see how informations are being sent across one department to another, right? So once what they just need to do is that type my name, and because they would have sent the information to another network within that the same to another topology, and because they have different, they call it segmentation, you break network down so that in case there's a very big virus or intruder that is in your system, you can actually scale through and shut down one so that it doesn't affect others, right? So what topology helps is that it makes communication easy, right? So people don't, unlike before, will be if you want to do communication properly, if there is maybe the top floor, maybe organizations that have 16th floor, 17th floor. Imagine somebody just going to print a document and running down 16th floor to just deliver that document. It doesn't make sense. So what it does is that it sends that information down to the 16th floor and allows the whatever topological system they have there to access that information. Then the main system within that topology sends that communication to their own topology, which is maybe their printers, right? And allows that information to be printed out and have access to it. So that's how communication works. So topology helps in routing and communication. It usually involves complex wiring, right? Using fiber optics, category 4E cables, copper cables, and all. So that's what topology is, and it helps you ease communication within a segment, right? And that's how it works. Thank you. Do you understand now?
Yes, yes. Thank you very much. Thank you.
So
Okay, so I
yes,
want to ask a question about DMZ. That's demilitarized zone. Is it also a type of network segmentation?
the militarized zone is also what are you asking? Is it also a network segmentation, right? So
Is it a
now
type of network segmentation?
when we talk about networks, I don't think so. Now when we talk about network segmentation, right? There are a lot of routing process to a particular organization, right? Let's say we have top floor, second floor, um top floor, second floor, fourth floor, and all, right? So what network segmentation does is that it ensures communication between um each floors, right? So on the ground floor, there are systems operating. On the second floor, there are system operating down to whatever floor that is available or within the organization. So demilitarized zone is not actually a network segmentation process actually. So we'll be looking the network for basics. Network this thing by OTW. I'll sort out the book and get you. Sorry, let me correct that. Yeah, I just got some information. Sorry about that. So a demilitarized zone, that's DMZ, also known as it's actually a network segment that acts as a buffer, as an internal network, and an untrusted network like the internet. Um, what it does is that it's a part of network segment that allows that serves as a bouncer, right? More like, should I say, can we call a firewall a bouncer, right? So it analyzes network traffic, right? And before it sends communication directly to the internal network, right? And without exposing the entire network to everybody, right? So a DMZ is a network segment. Sorry about that, and sorry for the misinformation. So just to clear the air, right? So it's a network segment that allows that kind of serves as a bouncer, like it blocks traffic or any kind of traffic and segment those traffic from the external network, like from guests. That's why in a banking system, right? In a banking system, they have what they call internal infrastructure and they have the external infrastructure. So if you want to sniff communications through an external infrastructure, like maybe a public, their own banking Wi-Fi, right? you can actually sniff communication, but maybe it will only be the staff that you may get informations about because they are actually connected to that particular network segment. So what it does is that it separates the main internal network, that's the bank processes, right? Of how that's because with MITM you can literally enter into the bank, like being the bank network, understanding and analyzing their communications through Wireshark. So one thing that DMZ does is that it sends like people that because most times some people may not even have data and they will come, okay, they may meet the customer service and be like, oh, I want to connect to your Wi-Fi, this that. They don't. There is an internal structure. Yeah, there's an internal structure. There's an internal network communication that happens, right, in that particular network. So what it does is that it segments the traffic that are coming in from the guest to the internal network so that you don't have access to internal infrastructures and be able to read internal communications that are coming from within internal network, so that you can read those communications that are coming outside from the internal network. So it's a kind of security block, right? So now, if I want to perform an MITM and I want to be like in the bank, um, like I want to get a lot of information from the bank system, right? So it actually blocks that communication and help me and allows and differentiates between who is a guest and who has the authority to access that particular information within their own internal network. That's why if we get to addressing and when we get to IP addressing and subnetting, you understand that we have, despite a bank and they have their internal network infrastructure and they have the external network infrastructure. So DMZ help in masking the process. So it takes you as a guest coming in from a different IP address. It takes you as a guest so that a guest does not access internal bank information, right? Then internal information is internal. So everything, the bank processes and all are being structured on an internal network structure. So that's so. Hope that answers your question, Simon.
No question.
John, John, any question?
Yes, Aruk. No, no, no,
What?
no, not at all.
Hope that answers your question. Okay, so that will be the end of the class today. So we'll see you guys on Saturday. So there'll be no assignment. The only assignment you are meant to submit is the one I gave you, right? So by Saturday, I will be requesting and marking each and every one of them. So thank you guys for attending. We'll see you on Saturday.